Hello everyone, welcome to my YouTube channel. My name is Bappy Ahmed and I'm your host. So guys, in this video, I'm going to teach you one amazing MLOps tool called MLflow. Okay. So this is the most successful research in the field of MLOps, okay, called MLflow. So guys, MLflow is nothing but it's an open source platform for the machine learning lifecycle. Okay. So if I talk about this MLflow, so it has these four major blocks. Okay. So MLflow has MLflow tracking. Okay. So actually you can track your records. Okay. You can track your experiment using MLflow. So basically it's a experiment tracking tool. So let's say whenever you try to do development, okay, at that time you do lots of experiments, okay, with the different model parameters. Okay. So these kinds of parameters tracking actually it can do with your data also, okay, with your parameter also, with your loss and accuracy also, everything it can track. Okay. So that what you don't need to do, you don't need to create any Excel file separately, and you don't need to log these are the information manually. Okay. So everything can be done using MLflow automatically. Okay. So this is a completely one amazing tool. And after learning this tool, actually you will be loving a lot. Okay. Because I started using MLflow in my every projects, because whenever I try to do any kinds of development, okay, I do lots of experiment with different parameters. So it helps me a lot, okay, to log my parameters. Okay. And not only you can log the parameters, but also you can deploy your model also using MLflow. Okay. You can do the model registry there, and you can select whether this model would be in a staging for you can say area, or it would be production area. Okay. You can select these are the thing. I'll show you these are the thing. Okay. Once I will start with the code example. So you can see it has this four major blocks. So MLflow tracking. Okay. You can do MLflow tracking using MLflow. MLflow projects also you can implement, like you can package data science code in a format to reproduce runs on any platform, because it can support various platform. Okay. I will show you like what are the integration actually it already has. Okay. So as you can see here, deploy machine learning models in diverse serving environments. Okay. Using MLflow. And it can do also model registry. I already talked about, okay, like store, annotate, and discover, manage models in a central repository. Okay. So this is completely one amazing tool. Okay. I will show you like how it will work. But first of all, let me show you the integration of the MLflow. See guys, it can support all the machine learning framework, okay, actually you use usually, okay, in your development phase. As you can see, it is also supported TensorFlow, PyTorch, Keras, okay, Spark, Scikit-learn, Hugging Face, okay, then DagSub. Okay, see, even if you are using R programming language, it is also supported there. See, everything it can support. Okay. I don't think beyond that actually you have anything else, but we mostly use these are the actually services. Okay. These are the framework. Okay. Whenever we try to do any kinds of machine learning development, okay, machine learning project development, and it can also support your AWS and Google Cloud. Okay. Even your Azure Cloud also. Okay. And guys, these are the organization actually using and contributing to the MLflow. As you can see, Databricks, Microsoft is there, RStudio, Facebook. Okay. See, these are the different organization and company. They are contributing and using this MLflow, okay, broadly. So guys, yeah, so this is a small introduction of MLflow. Okay. And if you are still confused, like what is MLflow, why we should use MLflow, okay, instead of just manually logging out information. So I will tell you like why you don't need to do it. Because see, let's say if you're working with a machine learning project there, let's say you are taking one algorithm, and that algorithm has different parameters. Okay. So what you are doing actually in just first iteration, you are changing a parameter, okay, with a specific number, and you are observing the accuracy or losses. Okay. Then if your loss is not increasing or decreasing, again you are changing the parameter. Okay. And let's say you have opened up one Excel file and you are logging the information manually there. Let's say this is the first experiment. Okay. In that experiment, that was the model parameter, and that was my model accuracy or model losses. Okay. Then again, you will be doing the second experiment. Then again, you need to save the information or log the information manually. Okay. So what you are doing actually, you are doing lots of manual tasks here. You are ending up with lots of effort here. Okay. To reduce this effort, MLflow helps you. Okay. You just need to provide one line of code, and whenever you will be like logging these are the information, it would be automatically logged inside the MLflow environment. Okay. You can launch up the UI, and you can see all of your experiment, and you can also do the comparison there, like which experiment got like higher accuracy or lower loss, okay, you can select that specific model with the specific parameter. Okay, so this will help you a lot, guys, just trust me. So I'll suggest just try to stay with the video, try to learn this MLflow tool. And definitely if you are learning this kinds of MLOps tool, okay, with your data science project, or let's say with your data science skill, definitely it is going to help you a lot to crack any kinds of you can say data scientist interview. Okay, because nowadays actually companies are looking for a developer who knows these kinds of MLOps tool already. Okay, so I'll enhance this playlist. Okay, I will add some more videos, okay, on the MLflow. Let's say I will bring up some end-to-end projects. I will try to integrate this MLflow with that. Okay, and I will show you like how you can use MLflow. Okay, even I will show you like MLflow on cloud. I will use AWS cloud, and I will set up the MLflow there, and I'll show you like how you can log your experiments, okay, on the cloud also. Okay, so everything I will show you, don't worry about. First of all, let's see a demo, okay, about this MLflow, like how it works. Once you got an understanding on this example, okay, then I will show you different real-time example. Okay, so to start with MLflow, actually they have given one beautiful documentation, so I'll refer the documentation and I will show you like how it works. So here you can see there is a documentation tab, just click on it. Okay, so here this is the documentation, guys. So if you want to read about more of the MLflow, okay, so you can read it. So here I just want to show you say Python API. So if you're using Python, so you need to see the Python API, like what are the APIs it supported already. So as I already discussed, it supported lots of you can say framework. As you can see here, it supported with Fast AI. Okay, then it supports with Onyx, then your PySpark, PyTorch, TensorFlow, Scikit-learn, okay, transformers, XGBoost, okay, OpenAI, SageMaker. Okay, so everything it has supported. Like the usually what are the framework actually we use, okay, in our day-to-day environment. Okay, all the integration you can see here. Okay, so today actually I will show you one basic machine learning example. So there actually I'm going to use Scikit-learn. So I'll be using this API. Okay, if you click on this API, you can see all the API function, all the things actually they have written here. Even they have given the example as well. Okay, so I'll show you like how to get the example and how to start with. So for this actually you can see there is a option called tutorials or example. Let's click on it. Okay, and here you have something called train, serve and score a linear regression model. Okay, let's take this as example and try to understand like how MLflow works usually. Okay, so I'll click on it. Yeah, so here if you just go below, let's say if you're using R programming language, you can select R. I'm going to use Python programming, so I'll be selecting the Python code only. Okay, so this is the code actually we'll be using. So first of all, what I will do, I will open up my local folder. Okay, so here I will create one folder called MLflow basic demo. Okay, inside that I will open my VS Code. So let me open my terminal. Okay, so first of all I will open my VS Code. You can also open up your VS Code here. So guys, I already opened up my VS Code here. So what I will do, first of all I will create one file here called example.py. Okay, and with that I also need to install some packages. Okay, so I need requirement.txt. Okay, yeah, so these two files actually I need. So first of all I need to create one virtual environment. So let me create the environment, let me clear it. So I'll just write conda. Let me zoom a little bit. Yeah, conda create hyphen n. Let me give the environment name. I will give MLflow test. Okay, MLflow test, and I will provide the Python version, Python equal to uh, 3.7 I will take. Okay, or let's say 3.8 I will take. Okay, 3.8 hyphen y. Yeah, now let's execute. So environment is creating. Now it's done. Now you can execute this command to activate your environment. Conda activate ML flow test. Okay, Yeah, so I have already activated. Now first of all, you need to install MLflow. Okay, so how you can install MLflow? Just go to the documentation. So they have already written you can use pip to install the MLflow. But one thing I just want to show you, let me open this tab. If I go to MLflow, here they have released actually MLflow 2.0. Okay, this is the current version. Okay, and with that version they have integrated a lots of things. Okay, so we'll be installing this 2.0 version, okay, of the MLflow. So what I will do, I will open up my requirement.txt, and here I will just write MLflow equal okay 2.2.2. okay, so this is the specific version actually I'm going to use. Yeah, so if I need any other package, okay, I will install it later on. Now first of all, let me install this one. So I'll open my terminal and I will just write pip install -r requirement.txt. So guys, as you can see, installation is done. Now I will minimize this screen. Now what I will do, I will open my example.py and I will copy the code here. This is the example code I already showed you. This code actually I'll be copying. Let me copy everything. Okay. Now I will open my example.py and I will paste it here. Okay. Now let's see any packages are needed. So first of all, I need to select the environment I created called MLflow test, I think. Let me refresh. Yeah, this environment. Now let me see whether, yeah, so everything is fine. Okay, so I'll explain the code. So this is a basics like code. They are using wine quality data. Okay, I think you are familiar with this data set, guys. Let me show you. If you have already worked with machine learning, I think you should be familiar with this data, red wine quality data. Okay, see guys, this is the data. So basically you have some columns. Okay, let's say fixed acidity, volatility acidity, okay, citric acid. Based on that, actually you need to predict the wine quality. So this is one regression problem statement. So this data set they are using. Okay, see here I'm not focusing on the data set, or let's say any kinds of ML projects here. Okay, instead of that, I'm showing you the process. Okay, once you learned it, you can use any kinds of data set. You can use any kinds of, you can say, EDA experiment. Okay, and you can perform these kinds of MLflow operation. Okay, so why I'm using this wine quality data? Because this data set would be a little bit easy for me to explain, because this data set is already you can say clean data set. Okay, I don't need to perform any kinds of feature engineering here. Okay, so that's why I can use this data set. Now as you can see, first of all, it's importing some of the necessary libraries. Okay, with that, as you can see from the scikit-learn, it is importing mean squared error, mean absolute error, and R2 score, because this is a regression problem statement. That's why these are the accuracy metrics you need. Okay, I think this should be clear, because you already know the machine learning I'm expecting. Then scikit-learn itself, I'm also importing trend test split. Okay, because you need to because you need to split your data in a trend and test form. Okay, that is why. Then from scikit-learn, they're importing elastic net. Okay, I think you already know the elastic net. This is the another variant of linear regression you can talk about. Okay, this architecture actually works better apart from your linear regression. Okay, so that's why elastic net they're using. Then URL parts they're using. Why, I will tell you. Okay, then importing MLflow. From MLflow itself signature, they're importing this thing. Then from MLflow, okay, they're importing scikit-learn. Okay, as I already told you, it has different APIs. So here, if I click on Python APIs, see, this is the scikit-learn APIs, sklearn APIs. Okay, now if I click on it, see, this is the API actually we are using, because this is a machine learning problem statement, and we'll be using scikit-learn, okay, for machine learning. Let's say if you're using TensorFlow, at the time you need to give just MLflow.tensorflow. Let's say you are using Keras, you need to give just MLflow.keras here. Okay, that is the change actually you need to do. Otherwise, everything will remain same. Okay, and I will show you like what are the changes actually you need to do below. Okay, but as of now, let's consider we're only focusing on the machine learning projects. Okay, in future I will create okay some more videos on deep learning as well, so that you can get understanding on it. Okay, then they are doing some logging. Okay, so that's why they are also initializing the login string. Then after that, this is a simple function to calculate your RMSC score, MAE score, and R2 score. Okay, as you can see, they are using the same function they are calling here, mean squared error, mean absolute error, and R2 score they are calculating. Okay, and they are returning it because this thing I need whenever I will be calculating my loss. Okay, loss and accuracy score. Okay, then after that, here, first of all, they are reading the data. So as you can see, this is the data URL. So they are reading the data from this. Uh, this is the URL. Okay, let me copy. Now, if I open this link, see guys, this is the URL. Okay, they're reading the data from here, and this is the data. Okay, so they're using pandas to read the data. Okay, as you can see, and it is separated by semicolon. Okay, and if anything is going wrong with this URL, they're like handling the exception. Then after that, they're performing their tensor split. Okay, as you can see, they're calling the tensor split. Okay, then after that, they're separating out the data with the training set and testing set. Okay, and after that, actually, as you can see, they're taking alpha value and L1 ratio. Okay, so what is alpha value and L1 ratio? I think you know if you search elasticnet in sklearn. Okay, sklearn. So you will see this architecture has some different parameters. Okay, as you can see, alpha value and L1 ratio. Okay, apart from that, it has some more parameter, but these two parameters are very much important. Okay, if you tweak this parameter a little bit, you will see different actually results you will be getting at the end. Okay, so that's why they are following on these two parameter. Okay, called alpha value and L1 ratio. If you search any algorithm in Keras, okay, any machine learning model, let's say random forest, decision trees, you will see some different parameters. Okay, these are the parameters you can tweak, okay, during your experiment. But in this example, they are only following alpha value and L1 ratio. Okay, just to show you the demo, like how actually things work. Okay, now how they're taking this alpha value and L1 ratio, as you can see, they're using system.argv. Okay, this system.argv, basically whenever you will be executing your code, during execution you can provide this value. Okay, as a runtime, you can basically, it will take this as input. Okay, and it will store it. Okay, and if you're not giving anything, by default it will set 0.5. Okay, like how it is working, let me explain. So I will take another file. Okay, and I will name this file as argv. Okay, argv experiment .py. Okay, so first of all, I need to import sys package. As you can see, they are using system package to call this argv. So let me import. So I'll just import sys. So see guys, how this argv is working. So first of all, let me give you a simple demo. I will take arg. Okay, so I'll just call sys.argv. Okay, then I will simply print it, print args. Okay, now if I open my terminal, now one thing you just observe. Okay, now if I, let's say, execute my this argv experiment. Okay, this one, argv experiment, this file. Okay, this file I will be executing. Let's see, if I execute it, so you will see it will return me this file. Okay, as a list here, as you can see, as an argument, or let's say as an input, actually it is taking and it is providing this thing. Okay, and I can take this file. Okay, I can take this file. Let's say not only this file, if I give any number here with that, let's say if I give any arguments, let's say 4 5 6, if I give it, see, with this file it is also giving this 4 5 6. Okay, as an argument here. So what I can do, actually, I can easily take any of the file here. Let's say I only want 4. Okay, so what I will do, I'll just give 1 here. Okay, so it will take the one number of example. So if I execute it again, see, it's only printing the 4. Okay, so that's why. Now let me copy the code. Okay, how it is working, I'll copy as it is. Okay, I will paste it here. Okay, and I will print my alpha and L1 ratio. Okay. Now what is happening? Let me show you. Now if I execute it again, Python argv example.py. Okay. See, if I am not providing anything, okay, if I am not providing anything, if I am only executing argv experiment.py, so it will take by default this number, okay, 0.5, 0.5, as you can see, 0.0.5, okay. And what is happening actually, I'm first of all checking whether user has given any argument or not. If it is given any argument, okay, so the first list would be what? First list would be this file itself, but I don't want the file, okay. I want only the number. That's why I'm calling for the first index. First index means it will give you the number, okay. So that's why I'm taking the number. And first of all, I'm checking whether this arg, okay, system.args length, okay, if it is greater than 1, that means if it is greater than 1 means like if you're not giving anything, that means this file would be itself only, okay. And if it is greater than 1, that means there is a number, okay. If there is any number, then just take that argument, okay, otherwise replace with 0.5, okay. Similar wise, I'm doing it for the my L1 ratio. I'm taking the last index, okay. That means index number 2, as you can see, index number 2, because first index would be your file itself. I'm taking the index number 2, and again I'm checking if the length of, if it is like, see, 1 2, if it is greater than 2, then just take it, okay, otherwise don't take it, otherwise replace with 0.5, okay. And convert it to float, because as you can see by default it would be string, okay, but I want to convert it to floating value. That is why, okay, I'm doing it. Now if you pass anything here, let's say any number, let's say 34, so instead of 0.5 0.5, it will replace with 334, okay. So that's why you can pass any kinds of arguments, okay, during runtime, okay, using this argv you can say attribute, or let's say argv function, okay. So this is the thing I just wanted to explain. So this thing actually they are using inside their code also, okay. Now your MLflow will start from here. So this is the line actually you need to add. You just adding with MLflow.start run, okay. Inside that I'm training the model. As you can see, first of all I'm initializing my elastic net. I'm providing this alpha value and L1 ratio user provided, okay, and random state. Then I'm training the model, okay, as you can see. Then after that I'm doing the prediction on my test data. Then I'm calculating the evaluation metrics, okay. This is the function we created, I think, remember. It will take your actual and prediction value. So I'm giving actual and prediction value, okay. It will return you the RMSC score, MAE score, and R2 score. After that I'm logging, okay, I'm logging, or I'm printing then, like you can say metrics, okay. As you can see, the stick knot, this is the alpha value, this is the L1 ratio. With respect to that, this is the RMSC score, MAE score, and R2 score, okay. Then after that, here you can log like that. So you just simply call MLflow.log params, okay. First of all, to log your parameter, you need to call log params, okay. So how many parameters we have? We have only 2 parameters. One is like alpha, I'm logging alpha, and one is like your L1 ratio, okay, L1 ratio. Then to log the metrics, you need to call something called log_metrics, okay. How many logs, how many metrics we have? We have 3 metrics, RMSC, ME, and R2. As you can see, I'm logging one by one. After that, this line of code is not required. If you remove it, okay, it's completely fine, no issue. They're just taking the signature, okay, because this is the official demo, so this signature is not needed, because later on whenever we'll be using our URI, tracking URI, at that time we'll be removing this thing, okay. As of now, you can ignore this line, this is not required. So this is the main thing. So tracking URL type store. So basically it will check whether this is a file type or URI type. Let's say if you give any kinds of URI, I will tell you what is URI. Let's say you want to log everything on the remote cloud, or let's say remote server. At that time you need to provide one URI, okay. URI means URL, like where you want to store that logs, okay. And by default, if you're not giving it, it will take file, okay. It will take everything as file type, because it will log everything in your local file itself, okay. That is why it is checking if tracking URI store not equal to file, track everything on the cloud, or let's say remote repository, okay. Otherwise, track everything in our local system only. So as of now, we are not using any tracking URI. It will be logging everything in our local, okay. And whenever we'll be using tracking URI, at that time it will store everything in the remote server, okay. And here it can also do the model registry, as I already told you. See, it will take your model name. So you are registering your model with the name of elastic net wine model. You can give any name here, okay. With that, they are providing the signature. You can also remove this line, no issue with that, okay. So this is the simple code, okay, nothing new. Only you need to add this line of code, okay, to track your MLflow parameter, okay, MLflow experiment, and these are the log actually you need to do. Okay, now let me save it and let me execute and show you like what will happen. Okay, so I will open my terminal, I will clear it. Okay, so now let me run example.py. So first of all, I won't be giving any parameters here, okay, in the runtime, because I want to first of all try with 0.5, 0.5, okay, as I already showed you here, 0.5, 0.5, okay. Alpha should be 0.5, L1 should be also 0.5, okay. Now let me execute. See, left hand side, it will create one folder called ML runs, okay. See guys, execution has been done, and you can see this is the log it has did, okay. Elastic model with this alpha value and LOL ratio. This is the RMSE score, MAV score, and R2 score. Okay. Now left hand side, you can see it has created one ML runs folder. Now let's me expand. See, this is the parameter log it has done. Okay. So first of all, it will create one dot trash folder. So it's not needed. Just open this experiment 0. Okay. Here, if you see, it has created one, like you can see unique IDs. Okay. First of all, it will save some metadata. In the metadata, actually, it will save you the artifact location. Okay, like why it has saved the artifacts, as you can see, it has saved this is the location inside ML runs inside 0. Okay, so this is the artifacts location, and with that actually it will also like tell you the creation time, which time you ran, experiment ID, last updated time, okay, life cycle stays active, and name default. Okay, so these are the metadata actually it will save. Now let me expand this one. Okay, yeah, as you can see, inside artifacts it will store all of the model. Okay, see, this is the model.pkl. Everything it would be done automatically. You don't need to save the model manually here also. Okay, so here with that it has also given the conda environment actually you used, which Python version you used, with pip version you used. Okay, with that what are the package actually you used. Okay, everything it will give you. Okay, if you want to create the environment, so you can use this conda.yaml. Okay, then this is your ML model. Okay, this is the ML model configuration and all, and this is the model.pkl file, and this is the Python environment. Okay, and this is the requirement.txt also. It has all automatically generated. Okay, what are the requirements actually it used, okay, in that code. Although we mentioned just only MLflow, but MLflow has dependency on this scikit-learn, okay, numpy, pandas, these are the thing. So that's why it is giving the separately requirement.txt. Okay, now this was the artifacts. Now inside metrics, it will save all the MA metrics. Okay, then your R2 score, then your RMSE score. Okay, so everything metrics it will save. Now it will also save the parameters, your alpha and LOL ratio, which is nothing but 0.5, 0.5. Okay, and in the tags it will save some metadata. Okay, related to your experiment. See, this is the user. My username is like book here, so it is giving Bhakti here. Okay, yeah, so that's how it will save some metadata information. Okay, see, everything it has saved here. Okay, you can go with these are the metadata, you can see, but main thing you don't need to check from here, because this thing is still confusing, because again you can expand lots of folder and you need to see like what is the accuracy score and what is the R2 score. Okay, and what was the parameter. So this thing is like a little bit confusing. Okay, now to see this in a UI, okay, beautiful UI, so what you can do, just open up your terminal again and just write MLflow UI. Okay, if you just write MLflow UI, it will launch one local server. Okay, and it will show you all the results there. So see, this is running here. So now let me open it up. I'll press Ctrl and right click on it. Now if I open it, see guys, it is running here, and this is the experiment actually we ran. Okay, 3 minutes ago we just ran this execution. Okay, and this is my model. Okay, this is the source, everything it is giving. Now if you want to see that, now guys, if you want to see that, just click on this name. Now see, this is your model. Okay, this is your model, it has already logged. Okay, now these are your tags. By default there won't be any tags. Okay, this is your metrics, this is your MA score, R2 score, as you can see. This is your parameter. Okay, which parameter actually you've used. Okay, and this is the description. We haven't given anything. Okay, see guys, everything it has logged and everything it is showing in that beautiful EI. Okay, MLflow beautiful EI, everything you can see. Okay, visually everything you can see. And if you click on model, by default actually it don't work in the local. If you want to do the model registry operation, at that time you need to use URI. Okay, I will show you like how to register your model as well. So as of now, let's do some experiment. Okay, as of now. Okay, see, this is the thing actually you have, but this is only one experiment we have done. But let's say I want to do multiple experiment. Okay, now let me run my code again. So what I will do, I will take another terminal here in the same location. I will activate my environment because that UI is running there, right? Conda activate MLflow test. Okay, now let me run Python example.py. Let's give our alpha value as 0.8 and interval ratio 0.7. Okay, now let me execute. See guys, this is the second iteration is run. Now if you unexpand it again, if you click on 0, see this is, so basically it will create another ID. Okay, as you can see, this is the another ID. Now to check it, just come here and you can see this is the refresh. It is telling just refresh because it has seen one new changes there. Now let me refresh. See, this is your last experiment you did, okay, 20 seconds ago. And again, if I open it up, these are my models and all, every information it has saved here. This is the metrics, okay, in the iteration, and these are the parameter. I have given 0.8 and 0.7. Okay, see how beautifully it is logging everything. Now let's say, let me do like run two more time. I'll give 0. Let's say 4. Okay, my L1 ratio 0.4. Okay, now let me run one more time. I will give my alpha value as 0.2. Okay, now if I go back, go to experiment. Now see, 4 experiment I did. Okay, now if you want to do the comparison, okay, so what you need to do, you can do the comparison. Okay, you can select like which experiment you want to do the comparison. You can select and click on, there is a button called compare. Okay, if you click on compare, you can see, okay, you can see the alpha parameters and metrics, okay, with respect to that. So there is a like you can say plot called parallel coordinates plot. Okay, as you can see, so this is my alpha value 0.8. okay, and this is my MAE score at that point of time. Okay, so it's showing like that. Now let's say if you want to add also your L1 ratio. Now as you can see, with respect to your parameter, it is showing the MAE score. Okay, so see how we can understand this one. So I have given parameters alpha and interval ratio. Okay, as you can see, this is the alpha for my experiment, like model experiment 1. Okay, and this is the alpha for model experiment 2. Okay, and this is the L1 ratio, which was like same at that point of time. Okay, which was same at that point of time, and this is the MAE score. Okay, and this is the MAE score. Now MAE score is nothing but it's like a loss. Okay, so the less loss actually you have, that means this model is better. Now how you select the model? So you will take alpha value nothing but 0.8. okay, and your L1 ratio 0.4, and you will be ending up with the MAE score nothing but 0.5. okay, so this is the matrix you let's say selected. Now 0.8 alpha and L1 ratio 0.4. Now let's say which model I got that. Okay, let me go back. I think this was the 0.8 and 0.4, right? Now if I come here, parameters, not this one, I think second one most probably. See 0.8 and 0.4, that means this is the model. Okay, this is the experiment. Okay, this is the experiment you can use. Okay, this experiment actually you can use this parameter, you can select. Okay, and you can give this parameter to your final experiment and you can train your model. Okay, but let's say this was only 2 experiment. Now I want to compare all the experiment together. Okay, I'll select everything, click on compare. Okay, now see again it will show you the same thing. Now you can add alpha, okay, all the thing. Now I will also add my RT score and my RMSE score. Okay, now see, this is the graph. Now as you can see, this is the alpha value 0.8. this is the L1 ratio, okay, which is nothing but 0.4. this is the MAE score you got, this is the R2 score you got, this is the RMSE score you got. Okay, just try to observe like which experiment actually did better. Okay, based on that you can select from here only. Okay, as you can see. Okay, as you can see, every log it has there, you can select from here only. So guys, here how to select like the proper runs actually, okay, with respect to the metrics. Okay, so let me show you, because as you can see, this thing is not like understandable, like which one is like our first run, okay, which one is like our second run. Okay, as you can see, because it's running four runs. Okay, as you can see, 4 ID I have. now which id is giving like better accuracy for you. Okay, so for this actually how we can select it. So first of all, see the lower so first of all select your metrics. Okay, first of all select your alpha and L1 ratio. Let's say I can see here actually I have very less MAE score, and here I have very less RMSE score. Okay, and here I have very high R2 score. That means this model is pretty good because my loss is less here and accuracy is high. Okay, and what was the parameter at the time? It is alpha value is 0.2 and L1 ratio is 0.4. Okay, now below just find it out. Okay, so this is the runs ID. You have different runs ID. So I have 4 runs. Okay, now just find alpha value 0.2 and L1 ratio 0.4. So below you can see alpha and L1 ratio 0.2 and 0.4. Okay, that means this is the run. Okay, and just go up a little bit. See, this is the run ID. Now if you open it in a new tab, now if you just go to the parameter section, see 0.2 and 0.4. With respect to that, I have, these are the parameters. Okay, you can compare with this graph. Okay, 0.2, 0.4. This is your MAE score, RT score, and RMSE score. Okay, that means that's how actually very easily you can get the information. Okay, now let's say you want to select another one. Okay, let's say second model which is better. So if I show you, this is the MAE score. This is the MAE score. This is the RT score, and this is very high. I think this one 0.5 and 0.5. Okay, now find it here. 0.5, 0.5. That means last one. Okay, now this is the commit ID. Now open it up. Okay, now if you go to the parameter, see, you can select. Okay, that's how you can easily go with that specific runs. Okay, where actually you got that best accuracy or best like you can say metrics. Okay, you can easily select. Okay, now you can go there. You can go to the model. Okay, sorry, go to the experiment. Okay, and see, you have already opened that one. Just see the run name, melodic moth. Okay, moth 453. So melody moth 45. See, this is the runs. Okay, now open it up, and you can easily see that all the metrics and parameters. Okay, you can easily get the information and try to use these parameters. Okay, in your final experiment. Okay, and you can train a better model. Okay, with that, that's how you can easily select your best experiment. Okay, okay, from this MLflow. Now not only see, you can also open up, these are the files and folder. You can see what are the things are there, as I already discussed in my local. Okay, even you can also open up this MAE score. Okay, and you can see is as a graph. Okay, it is also possible here. Let me show you. See, you can also open the R2 score. Okay, and you can see this is the R2 score you have here. Okay, every information you can see. Okay, so this is pretty much good tool. Every information you can see here. Okay, from this tool only. So that's how, see, beautifully using MLflow you can track all the experiment you are doing. Okay, with the different parameters, and you can log everything here. And at the end of the day, actually you can compare everything. Okay, with this parallel coordinates plot. Even not parallel coordinates plot, it has scatter plot as well. See, you can also import scatter plot here. Okay, you can also import scatter plot, and you can see which is your you can say L1 ratio, because scatter plot only you can plot on respect to one column. Okay, as you can see, alpha MAE score. Okay, this is the alpha value, with that this is the MAE score. Okay, that's how you can see. With that you have the box plot as well. Okay, so alpha R2. Okay, this is the box plot. With that you have contour plot as well. Okay, let's say alpha L1 ratio. Okay, with that RMSE. Okay, so these are the thing actually a little bit confusing. So I'll suggest just always focus on parallel coordinates, because you can see all the experiment together. Okay, this is beautiful plot. Okay, what I feel like, I usually follow this plot only. Okay, that's how actually you can select everything. Okay, now let me see whether I have anything to explain or not. Yeah, so these are the thing only, but this thing I'm doing on local, because every experiment it is saving in my local system here. Okay, but you can also save these are the experiment in your remote server as well. Okay, so in the next video I will show you like how we can save these are the experiment in the remote server. Okay, and there actually you can also do the model registry. I'll show you like how it will push the model there, and you can select the model, whether this model would be staging area or production area. Okay, you can also select from there also. Okay, so yes guys, this is all about your MLflow experiment. Okay, in the local system only I showed. So now you can pick up any kinds of data set. Okay, and you can just write this line of code and log up your parameter, log up your metrics. Okay, like that only, and you can save all of your experiment, okay, in the MLflow server, okay, as you can see, and you can do the comparison which model is working fine in this case, okay, as I already showed you. Just compare it, find the best possible parameters with respect to the matrix and select that experiment, okay. With that, actually, you can do it. Okay, so that's how actually you can select different experiment, okay, and the experiment actually working better for you. Just go with the experiment, okay. So yes, guys, see, if you're using MLflow to do the experiment, so you don't need to perform the hyperparameter tuning, because hyperparameter tuning again increase the cost, okay, because you will select lots of parameters and you will keep on running your model, so it will take those are the parameters and it will keep on running. So training takes time usually, but let's say, see, as a human, actually, you know, if you select these are the parameters, okay, so let's say you have 10 different parameters. Just try to give 10 parameters, okay, in 10 experiment, and you can see all the experiment, okay, and you can get like the good model, okay, from there only. So here actually you don't need to perform the hyperparameter tuning, because hyperparameter tuning actually increase the cost. And if you want to decrease the cost, and if you want to log all the experiment, okay, you can go with MLflow, because MLflow provides this kinds of capability to log everything, and you can manually compare everything there, okay, and you can see everything here. That is the best thing here, and you can also do the model registry, and in this thing you can also do the automation, okay. Let's say if you just click this model I want to use for my production, it will be automatically get deployed, okay. This kinds of like integration you can also do, okay. I'll try to show you, okay. I will create some more videos on it. So I just want to show you like how MLflow works, and this is the basics example I have given. In the next video, I'll show you the URI part. I will log everything in the remote server, okay. I'll be using DAX app for this. So yes, guys, this is all about for the MLflow. I hope you got it, okay. And if you have liked this video, just try to subscribe to my channel, try to like this video, and try to share this video, okay, with your friends and family, so that they can also able to learn, okay. And I will request try to learn this MLflow, okay, and try to integrate with your projects. I hope actually it will help you a lot, and you can crack any kinds of data science interview if you know these kinds of MLOps tool, okay. So in future I will create more MLOps tool video, okay. I will create different playlist on it. I will take DBC, I will take any other tool, okay, and I will create a video on it, okay. So yes, guys, thank you so much for watching this video, and I will see you next time.